Hello, and thanks for tuning in. If you're new to the channel, please hit the subscribe button. If you're joining us back, thanks. It means a lot. Today we're going to go into how to set up a Ammco brake lathe and how to properly machine a rotor to tolerance and spec. First thing you're going to need to do is clean off your brake lathe arbor. That's the shaft that's coming out that holds the rotor and all the cups. You want to make sure that's clean and free of any rust, debris, any metal shavings or anything like that will throw it off. As you can see, I sprayed it off and wiped it down. So the next thing you're going to have to do is get your rotor and clean the inside area of all the big rust particles. You're going to have to find a rotor adapter, hat, cup, end plate, whatever you want to call it. It's one of these guys. Find the biggest one that fits in there and sits all the way flush. That's your first piece that's going to go on. So now that you have that piece on, the very next piece that goes on is your spring. Slide the spring on. And you have to go back to the rotor, and in the center right there you have a bore, and you want to get a cup that fits in there, or a sleeve or a cylinder, I'm not sure what they're called, little cone. You get it in there to where it comes through and it doesn't go all the way through, so it'll grab the rotor. That's the very next thing that goes on. So you slide your cone on. Now the rotor goes up on next. Once the rotor's on, you have to find an end piece to fit. You get an end cup that fits on it. And then you start making your spacers out to the end. You don't want to get the feet lined up into the lug nut holes. So we'll get a spacer on there, which this is a rubber isolator spacer. It's a left-hand thread. Gonna go ahead and thread it all the way down. Make sure everything's nice, tight, and centered. And you just want to take this reverse thread nut and just go ahead and give it a couple little tugs. It doesn't have to be over tight. A couple little snug tugs. And that's it. Come back around to this side, you'll see the lug nut holes are here. And I have the feet off of them. You don't want to put the feet on them because that could throw out the runout balance. So we'll back up. And you want to turn the machine on and just see the overall runout. See if it's set up properly. And it looks fairly straight. What I'm going to do is I'm going to re-loosen it. Kind of spin the rotor assembly on the hub and the cone. Just to make sure there ain't no rust in between it. And nothing's getting trapped. So we'll just loosen it back a little bit. I want to just get that all dug in there and then tighten it right back up. Alright, it's tightened up. So we'll check the runout again. Looks pretty decent. I don't really see too much wobble. So we're going to get the silencer band on there, and then we're going to perform a scratch test to make sure that the rotor is actually true to the machine. We'll shut this down, back it out just a hair. Alright. So I'll get the silencer band on here. This just basically takes out the harmonic resonance from the cutting blades as the rotor is spinning around on here, so it don't make no noise. Back our blades all the way up. Now with the cutting head, you want to make sure it's square and parallel to the rotor. Tighten that down, make sure it's snug. And then we're going to go in and now we're going to perform a scratch test on both sides. If we get a cut of 180 degrees, 180 degrees or more around the rotor, which is halfway, 50% or more, then the rotor is good to turn. If it's not, we got to readjust our setup and or check the runout of the arbor. So now we're going to do a scratch test. Run in the head about halfway. You want to turn the cutter in right till it touches it. And do the same with the other side. Shut it down, back them off. So, as you can see, the cut starts about here. About right here is where the cut starts. And it goes about halfway around. So I'm going to go ahead and just re-loosen and re-center it again, because you want runout to be, you know, 1,000th or less. Especially on these newer vehicles. They'll give you trouble. You'll feel vibrations all throughout the drivetrain and everything. Alright, so we'll do another scratch test. You want to back the head out just a little bit. Turn it back on. Let's check them. Alright, so scratch test passed. Both lines, as you can see, line up on top of each other. They're not 180 out. So this rotor can go ahead and continue on with the machining process. So what we want to do is we want to turn it on. We want to run the head all the way back. Want to get as close as you can to the ridge back there, and we'll cut this ridge off. We'll go as soon as it touches. Same thing on this side. We'll see exactly where it's touching at. Alright. So we'll go a little bit more in. And we'll lock these down. We'll set our 0 marks on our handles here. Set them to 0. And we'll make a quick pass. I'm going to take a couple thousandths off, maybe 2 thousandths to start with. We'll see how that cuts. And we'll do a fast pass. Alright, you can see where the rotor has some minimal run out there and some wear. So we'll have to come through for another pass to clean it up again. Alright, once the cutter stopped, shut off the feed head, shut the rotor off. As we can see, there's slight run out right there in the very beginning of the rotor. Rest machined very well. This side machined extremely well. So I think we will take another 20,000. I'm sorry, another 2,000 off this side and a 10,000 off the other side. And then we'll make a final pass. As you see, I did not move the cutting heads at all. I left them in the same exact spot. We'll go right there till it bumps. That's how you know that you're in a spot that's good to start cutting. And this side, like I said, I'll take up another 2 thousandths. Tighten it down. I'll do 1 on this side. And we'll do another fast pass. See if it cleans it up. See if that shiny spot goes away. And as you can see, the spot's gone now. Alright, now that the fast pass is complete, we'll take a look at both sides of the rotor. As you can see, that runout spot is gone. It's perfectly machined flat now. Both sides are good. Now you'll do your final slow cut. This will be the finish. Well, this will be the last cut before doing the sanding of the rotor, which takes out the directional finish that this puts on, because you want a non-directional rotor finish. So we'll turn it back on. We'll run the blades all the way back in. Like I said, we're running all the way back to that rust ring back there, where the pad does not touch. Once we hit, we know we're good. Alright, we're there. So I'm going to loosen. I'm going to take a 10,000th off. Lock it down. Come over here. I'm sorry, not a 10,000, a 1,000. So I've taken a total of 10,000ths of an inch off both sides. And we'll run it on the slow feed now. And this will come back and take a few minutes to cut. Alright, I'm just going to pause the video because I'm not going to bore you with the slow cutting. We'll come back periodically in between and check it. Okay, we're back, and as you can see, there's a clear, definitive difference between the fast cut and the slow cut. The fast cut is kind of just your coarse, quick, getting it down to that level that is almost smooth and perfect, and then you throw on the slow cut, which will give you that final finish before you got to put on the non-directional finish. But we'll come back just as the rotor finishes up. Alright, we're approaching the end of finishing the rotor and the machining process. Just about to touch off the rotor on the end. Both sides look fantastic. I mean, this brake lathe is probably 30 years old. Easy. I'm going to try and find the serial number on it to see. But it's a super old brake lathe and it still performs. Just with a little upkeep and maintenance. Alright. So, turn that off. Back these cutting blades out. Take the silencer band off. And let's take a look at that finish. Try and get it as best as I can on there. I mean, that is an amazing finish. The whole way around. It's true, it's perfect. There's no wobble in it, there's no nothing, it's absolutely perfect. So what happens now is, because this rotor was being fed towards the cutting heads, which are right here. So it's being fed towards it. We want to put a non-directional finish on it because when it goes on the vehicle, depending on what side it's on, you know, it's like a corkscrew almost, because you're dragging a little diamond tip blade, tiny point like that, from the inside all the way out. And it's just, think of it as like a winding screw all the way out. So it's got little tiny ridge on it. I mean, it's smooth to the touch, but there's an ever slight ridge there, and you want to knock that down. So I got some 320. That's all I had laying around. It should work. And you want to turn the machine on. Just use the machine. Take your hand there and just kind of, not lose the sandpaper, but get your finger on there and, you know, hold it and move your hand up and down. Just put moderate pressure on it. It is metal, it's not going to hurt it. So you do that for a minute or so, and that's going to knock down that direction, and it's kind of swirl everything up, and you want to do that to both sides. What that's going to do is it's going to give the best surface available for that brake pad to seat into this rotor. And it should be good. So we'll take the rotor off. We'll look at it. Actually, hit it with a little brake clean. Some of that brake dust off there. Sorry, trying to get the camera down here. Look at that finish. Did a perfect finish. So right after I set the rotor down to show the finish and did a quick pan up and wanted to talk more, the light went out. So the rotor's back on the car, but it machined perfect. Like I said, super easy way to set up and run the lathe. You get the biggest cone, or the biggest, cone for the back, a spring, then you get a cone for the hub center, and then you get another adapter like that for the front of the rotor, and then you tighten it down with a nut and some spacers, and then one of the actual spacers, that one, it's rubber in the middle, and it's got like washers or something in there to absorb vibration and kind of straighten everything out. But yeah, stay tuned for more videos on this brake lathe. I'm going to clean it up, and this thing machines flywheels, can do a lot, drums, rotors, so I look forward to using it. Thanks for watching. Please subscribe.